Can I ask for a clarification here?
Yeah,
So
of course.
sometimes we use the term explosive, and then sometimes it's ignition. Should we be making a distinction between something exploding versus something catching on fire?
They're used interchangeably, to be
Okay.
honest, in the market. So, like, even when you read the standard, for example, you'll see it says flame proof instead of explosion proof.
Okay.
But the meaning is pretty much the same, where an explosion proof enclosure means that, the explosion is contained inside the explosion, but the standard calls it flame proof,
Okay.
where the flame can't exit the enclosure.
Okay.
Yeah. So these are some of the examples of ignition sources. And then, some of them relate directly to specific standards, for example. And again, not all would be applicable to your product. I think that was one of the main questions in your email, Ray, that
Yeah.
I'd provided a list of standards, or someone had provided a list of standards in the past. But again, not everything can be applicable to your product. So these are, some of the basic protection strategies, to prevent any explosion atmosphere from coming into contact with any part of the equipment. That could be an ignition source, preventing the equipment from producing an ignition source itself, designing equipment to contain an explosion if caused by an ignition source that is part of the equipment. So this is something that would fall under a flame-proof enclosure, for example. And then diluting the flammable atmosphere in contact as well, and de-energizing the equipment. So again, these are different protection strategies, at least some of the most basic that are used out in the market, just so you guys have an idea. And if anyone has any question, please feel free to just jump in.
Yeah, so I have some questions. So explosive atmosphere, what does that imply? Does that imply like a certain concentration of gases or a certain amount of oxygen? What does explosive atmosphere mean?
Yeah, so we'll get to that. It's part of this. We'll get to that. Yeah.
Okay. All right. Yep. I'll hang on.
Your questions will be answered.
Thank you.
Yeah. Okay. So basically, a hazardous area is one which there is an explosive atmosphere which is present or maybe expected to be present in quantities, different quantities depending on the zones, divisions that the area is classified as. So basically, again, this depends on what kind of area it is, whether it's a manufacturing plant, oil and gas, if there's propane present, things like that. So these are the two different classes. So for example, your current tool is certified for Class 1 Division 2. A Class 1 is basically a location in which flammable gases or vapors are maybe present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 2 is basically there is combustible dust present in the hazardous environment. And Class 3 is fibers or flying. So when we say Class 1, we're only talking about gases and vapors. So your product is only certified to be used in an area which has gases or vapors, not combustible dust or not fibers or flyings.
Okay. Luke, off the top of your head, do you know if we were trying to get Class 2 and didn't, or did it just not matter?
Off the top of my head, our customer requirement was Class 1.
Okay.
But we could explore the potential for pursuing a Class 2.
Yeah, and I'll get more into that Class 2 and the standards applicable for that, so you guys have a better idea of that as well. And yeah, so that's the basics of the classes, and then we get into the zone and divisions. So Division 1 is pretty much the same as Zone 0, where a hazard is present continuously or for long periods of time, or frequently, basically in the classified area. Division 2 is the same as Zone 2, where a hazard is present only abnormally or only for a short period of time. So back in the past, the North American classification was Division 1 and 2. But since IECX was adopted by CSA and UL, they're trying to move to the zone marking requirement, which is, globally accepted in this case, where if you have an IECX certificate for your product, but not a North American certification, the only requirement for you to obtain North American certification is for you to submit your IECX documents to a certified body that is part of the IECX scheme, and they would review those documents and pretty much do the national deviations for North America to CSA and UL standards, just because CSA and UL have adopted those IEC standards. The IEC is basically the base for the zone marking. And for ATEX, it's the EN standards as part of the directive, which are basically adopted from the IEC standards. So again, when we do an ATEX certification, the base is the IEC standard we're looking at.
Okay.
Now, yeah, go ahead.
Sorry, I was just going to ask a quick question. So with North American standards making the move to zone classifications, would we need to recertify our existing Class 1 Division 2 certification on our battery products that we have today?
No, they're independent.
Okay.
So the choice is yours. Do you want the zone marking? If you want
Understood.
the zone marking, as part of the ATEX certification, we can do IECX. It's not going to cost you anything significant. It's just documentation on our end, because the basis of the standard is the IEC standard that we're going to use. So our recommendation would be you get IECX and ATEX both, and that doesn't only restrict you to the European market, but you can take the products globally. You can take them to Japan, Taiwan, wherever you want, because they accept the IECX test reports for their own certification without any further testing.
Very cool. Okay, that's good
Yeah.
to know. Thank you.
So the one main requirement you need to keep in mind if you have an IECX certified product and you want North American certification, for the hazardous location, it's pretty straightforward. We do the national deviations based off the IECX test reports. But as you know, in North America, the requirement is your product must meet the requirements for general safety for 60204 standard that we certified the product to as part of North America, if I'm not wrong. Or I'll have to double check what that standard was. I believe I have it here.
Safety, I think on this particular product, it was 62841.
62841, yeah, correct. So again, those standards are adopted from IEC standards. So pretty much, a lot of the standards that IEC has are adopted by CSA and UL. Unfortunately, currently, we're not part of the IEC CB scheme certification, but we do have those standards in our test laboratory accreditation where we can do the testing and provide a test report, which you could potentially submit to a CB scheme laboratory to obtain an IEC certificate if required. Again, that's just for general safety. For hazardous locations, we're fully accredited.
Could you say a little bit more about what the CB scheme is?
So the CB scheme is just basically for general safety, similar to the IECX scheme, except IECX is for the explosive atmospheres, and the IEC CB scheme is just for general safety. So a lot of the times you'll see when you buy, off-the-shelf batteries or components, some of them would have an IEC certificate. So for example, batteries, I believe the standard is 61322 or 63122, something like that. You would see that most battery manufacturers would certify their batteries to that standard because that usually is accepted in North America with the CSA UL equivalent standards where they can do the national deviations on it without having to do further testing. So for them, it's an easier way to sell the product globally instead of just one market. Again, okay. Not every product requires IEC CB scheme, especially if you have a hazardous location product, that pretty much supersedes the general safety aspect of it. Because for the IECX scheme and ATEX directive, there's no requirements for general safety. But that's only because, that explosive atmosphere evaluation and testing supersedes the general safety where it's already stringent enough for you to obtain HAZLOC certification for those directives and schemes. So they're not too worried about the general safety, while in North America, it's the opposite. You have to start at general safety, then go to the hazardous locations. So any product that is certified for Zone 0 can be installed in Zone 1 and Zone 2. Any product certified for Zone 1 can be installed in Zone 1 and Zone 2. Products certified for Zone 2 can only be installed in Zone 2. Similarly, Division 1 products can be installed in Zone 0 and Division 2 and Zone 1. But again, that depends on the method of protection. So for Zone 0, there's only, I believe, 3 methods of protections that you can achieve to get Zone 1 Zone 0 certification. One is through intrinsic safety. The other is through encapsulation. And the third one is only applicable for catalytic sensors through the flame-proof method of protection. And I think there is the option of optical radiation, but again, doesn't apply to your product. And I'll show you the list of standards after this. So these are some of the gas groups that the classification pretty much uses. Acetylene, hydrogen, ethylene, propane. 2C is the most hazardous. So if your product is certified for acetylene, pretty much it can be installed in any environment that contains hydrogen, ethylene, propane, and vice versa. Group 2A is the least hazardous. So propane is the least hazardous in this case. So in the division classification, these gas groups are known as A, B, C, D, where D is propane, A is acetylene. In the zone classification, ATEX, IECAX, it's classified as 2C, 2B plus H2, 2B, and 2A. And then we have the maximum ignition temperature or temperature classification that you must have seen on your product. So that's basically how hot the equipment will get during operation. And yeah, materials with lower ignition temperatures will require a higher temperature code. So like the last statement which says if the requirement is for temperature T4 temperature classification, which is up to 135 degrees Celsius, you could still use this in anything below 135 degrees. So in a T5 or T6 classified temperature area as well. And usually T4 is, the most common temperature classification we come across on products. There's only certain products that can reach a maximum temperature of 450 degrees. So you don't see those that often as well. And basically this list or this table shows the differences, degrees in Fahrenheit, and the temperature class it reflects. And these are available pretty much on any certification body's website on their I would say, like a poster where it lists the different methods of protections as well. So you can always refer there.
Let me just ask for a clarification on what the temperature is indicating. Are we saying that, let's take T2, 300 degrees Celsius. Are we saying that is an ambient temperature that the device can withstand? Or are we saying that's the maximum temperature that the device will get up to under operation so that it doesn't ignite something else?
Correct. That's the maximum temperature where you can expect an ignition.
Max.
So basically at 450 degrees, if the product is certified, for example, T2, the maximum temperature that it can be used up to is 300 degrees during operation. So it can get as hot as 300 degrees Celsius. But again, a tool would not be that case, right? Like in terms of talking about your product. Your product would be, I believe the T4 classification is what you have currently on the BRAD tool for class 1 div 2.
Okay. All right. So that is describing a behavior of our tool. We're saying that our tool is T4 and it will never exceed 135 degrees Celsius.
Correct. And this is always determined by us as well. Even though you tell us, for example, T4 in your RFQ request, when we do the service temperature test, there's a table in the standard, if any of you have looked in the standard, that it follows. And there's, I think, about a plus or minus 20 degree that we have to consider based on the surface temperature.
Okay.
So this is basically, just showing like a different classification where there could be a zone 0, zone 1, and zone 2 environment all in one area. So if there is a zone 0 environment, again, like I mentioned, the methods of protection there would be intrinsic safety. Anything installed in zone 0 would have an intrinsically safe output to a zone 1 or a zone 2. That's the only way that equipment would be certified and to operate in such an environment, for example. Coming back to division, pretty much, it says Division 1 refers to Zone 1, a location in which ignitable concentrations of flammable gases or vapors can exist under normal operating conditions, in which the concentrations of gases, vapors may exist frequently because of repair or maintenance operations or because of any leakages. So again, it reflects the same as Zone 1. Division 2 reflects the same as Zone 2. So Division 1 counts as Zone 0 and Zone 1 in this case. So moving on to dust, again, Division 1, Division 2, same concept, except the environment is combustible dust, nothing different. The concentrations are the same as gases in a Division 1 environment or Division 2 environment, except there is only combustible dust and no gases present. So again, most of the time you would only find combustible dust in anyone doing processing logs or things like that, like timber or similar applications, normally not in an oil and gas application.
What I would also assume like coal operations would be dust environments. Yeah.
Correct. Coal environments. So a lot of time where people use some sort of conveyor belt machines in a coal environment, they would get that certified for dust.
Understood. Okay.
Fibers flying, same thing, except the environment has fibers and ignitable fibers and flyings. Same concentrations for Division 1 and Division 2. And then I think you were asking regarding the gas concentrations, I would say. So these are some of the concentrations that they describe in the standards. Again, if you look up the standards, you would be able to see there are different tables in the standard, depending again on the method of protection. And that would pretty much, again, most of these would only apply to, explosion-proof testing, for us to have that environment created with that much ignitable gas. Depending again on the method of protection, there's certain tests we have to do based on the standard. So again, not every test requires us to put your product into an environment that contains a gas to test. This is one of the test apparatus for that, pretty much where we can do the testing based on the gas requirements. And yeah, this is the gas classification. So like I was saying, A, B, C, D for the division marking. For the zone marking reflects 2A, 2B, 2C. There's 2B plus H2, which is for hydrogen. Again, test apparatus. So now we come to equipment groups, which is basically only for IECX and ATEX. Group 1 equipment usually is only used in mines. Group 2 equipment is more common, which is used in an explosive gas environment other than mines. So pretty much most of your tools would be in, Group 2 equipment classification because it's not being used in mines. Unless you do get into the mining sector, then that method of protection will change.
So we are in the mining sector, but I don't think that we're necessarily in the mine itself.
Correct.
I think we're in the haul trucks outside the mines, I think.
That's fine, as long as you're not in the mine. Okay. Yeah. So like I was saying, these are some of the examples of different gas and dust locations. And if there's any hybrid mixtures, then, clients would get their products certified for both gas and dust, just to give an example. Anyone has any questions so far other than Trey and Luke? Anyone else on the team? No? Okay. So when we get into the different certifications, pretty much, the US has their own, Canada has their own, Europe and other countries have their own government regulation requirements, or for clients to operate certain equipments require certain certifications. So this is where we come in. These are some of the standard bodies that develop the standards for us to certify the products to for you guys. So ISO standards, the so the ATEX directive falls under the European Union. CENELUC is what we call it. US is the UL standards. Canada is the CSA, so like Canada Standards Association, as well as they have their own laboratory group, for example, you guys probably know of, which is the CSA group. Same with the UL. They have a standards body and a UL laboratory for evaluation and testing and certification. TC31 is the committee for the IEC 60079 standards. I'm not sure if any of you worked with our previous senior engineer, Mark Koppler. He used to be a committee member, one of the, I would say, executives on the TC31 committee before he retired 2 years ago. So coming back to harmonization process, national deviations is what we talked about, that, it's adopted from the IEC 60079 standards, and the CENELUX EN 60079 standards are adopted from the IEC, same with the UL and CSA standards. When you get a product certified for IECX and ATEX, as long as it's a category 1 or category 2 equipment and not a category 3 equipment, your product requires, your manufacturing facility will require a quality assurance notification audit or a quality assurance report audit. QAN and QAR is what we call them. QAN is related to ATEX. QAR is related to IECX. They both go hand in hand. They follow the ISO 9001 system. So if you do have an ISO 9001 certification for your manufacturing facility, the audits, or I would say the QAR certificate validity is 3 years from the initial audit. It follows a surveillance audit after 18 months if your manufacturing facility is ISO 9001 certified. Same with the QAN. If it's not ISO 9001 certified, then we have to do surveillance audit every 12 months. And then after 3 years, we have to renew that certificate. Same process, initial recertification audit, and followed by 2 surveillance audits. Sorry, Luke, go ahead.
No, that was exactly it. So, we're not 9001, so 12-month audits. And then are those scheduled, or are they sort of like a surprise audit, or?
No, those are scheduled. Those are scheduled. We have to schedule those because when we issue you an IECX certificate, for example, that certificate is on an IECX database, which links to your QAR. So in the IECX system, we get a notification, or the client, usually we get that notification that the audit is coming up, because, when we put in that information in the system saying, oh, this client doesn't have 9001, it automatically tells us, okay, audit after 12 months. So that's something we usually schedule ahead of time just to make sure, you guys have availability of personnel to assist during the audit.
Understood. And then just in the nuts and bolts of that audit, our laboratories are ISO, and I've engaged in some of those audits, so I'm somewhat familiar with how we run that process internally. Mind you, we're auditing kind of our own internal procedures. Presumably, you're auditing the production of the product against the standard. So
Sure.
that'll be the production facility. And then, our internal audits, we don't do comprehensive, but we'll select, this paragraph, this subsection, look for those specific things. Is that sort of the flavor of it?
Yes, and I can share like our template of our report. So that gives you a better idea of what we are expecting during the audit. It's just a blank report. It'll pretty much list out all the sections that we look at. And most of the time, Kavinder does these audits locally for our clients located in the Lower Mainland. So he would, if there's any non-compliances, he gives you time to address those. You have those fixed till those are fixed, then he would issue the documents. So he'll work around it with you, not an issue.
Awesome. Thank you.
I want to just make sure I understood a couple of things you said. If I understood correctly, you said QAR is needed for IECX.
Correct.
And QAN is needed for ATEX.
Yes.
And in order to get ATEX, we would have to satisfy IECX as well.
No, they don't go hand in hand. You can have just ATEX. But again, now coming back, let's, for example, go back to your old proposal that was provided to you, right?
Yeah.
It was stated your product is for ATEX Category 3 for Zone 2 for Europe. As I mentioned, Category 3 products do not require a quality assurance notification. So if we're still targeting the equipment to be a Category 3 equipment, and I'll pull up something for you guys to see here. Give me 1 second. Okay, I'll share this table, for example. You can see this, right?
Yes.
Okay. So usually, like I said, you can access these tables anywhere online. Just search up IECX zone system, ATEX zone system, and you'll be able to get this. So as I mentioned, they have an ATEX category. Each standard or each method of protection, for example. When we're talking about increased safety for Zone 2, which is equivalent to Division 2 in this case, it is classified as an ATEX category equipment 3, which is where there is no QAN required. This is basically when you take your product to the European market, what you're going to do in your when you declare for CE conformity, you would declare it with our test report, and that's the process. It's a self-declaration, manufacturer's declaration, and pretty much the ATEX directive, like I mentioned, supersedes any other directive like LVD or any of that. So for example, we did that, I believe it was the low voltage directive on the product, if I'm not wrong. Pretty much once we do ATEX, you just use that report to do your CE declaration. You don't need that LVD directive, basically. So yeah, in your case, there's no QAN required if we're certifying the product for Zone 2. But if you say we want the product certified for use in Zone 1, then the QAN comes into question. Right?
Right. Okay. So I know we are audited for something every now and then by Labtest.
Yeah.
Does anyone know what that audit is?
Yeah, they're the follow-up inspections quarterly for your current listing with us. So basically, we've given you the authorization to mark your product with our marking.
Yeah.
So we just come in quarterly and check in that everything is as per process, as per the report we provided you, and all the processes are being followed, and there's no non-compliances. That's it.
Okay.
I believe those audits are probably an hour or two.
That sounds right. Is that separate, or is that overlapping with QAR, QAN?
So if we're doing a QAR, QAN, we can complete one of those the follow-up inspections at the same time. Again, depending on how it aligns with the schedule. So that's not an issue.
Okay, but the audits that we're doing currently are not going to be satisfied. Okay,
Correct.
gotcha. Thank
Correct.
you.
Yeah. But again, not required in your case if we're going for the Zone 2 application for ATEX.
Right. Although
because that falls under Category 3 equipment, right?
Okay, right. I had listed Zone 1 as well in our requirements.
Yes. So
Yeah.
I'll get to that after this.
Okay.
So going back, let me see. Okay, there we go. So that's the basis of, adoption of standards, harmonization of different standards from IECX, ATEX to North America. Now we get into the different methods of protections that we've been talking about. So basically, there is standards for electrical equipment and there is standards for non-electrical equipment for certification for both IECX and ATEX. So -0, this is the standard series 60079 is for all standards related to hazardous locations. -0 is a general requirement. Anytime you get a product certified for ATEX or IECX, that's going to be the base standard. So if you guys don't have access to that standard, I would highly recommend you guys, download or purchase the standard, which is IEC 60079-0. I believe the latest edition is 2017 or 2018. That pretty much is the basis of everything you would design for zone classification. If you would like to get ATEX certification or IECX certification, that is one standard I would recommend you guys to read over. It pretty much has tables, requirements, creepage, clearances, IP rating requirements, everything, most basic requirements for a product to be certified for IECX and ATEX.
Sorry,
and I know one of your question was for IP rating. Sorry.
The standard you're referencing there was the -0?
Yes, that's the basic standard.
So yeah, talking about IP rating, because originally we were looking at
IP
the
55.
increased safety protection, which I think is -7, which required the IP 54 or better
Correct.
rating. So when presented with this information that you've got up on the screen right now, what does 60,079-0 versus -7 enable us to do in the market, so to speak? Just help. I always struggle with this. Just help me connect the dots a little bit.
Yeah, for sure. In fact, I'll pull this up here so it'll make it a bit easier for you guys. So usually if you just search up the standard, there's usually an area which says the scope. And pretty much the scope would say, let me see if this one's going to show it. Okay. Okay, let me just pull something up for you guys here. Yeah. So basically, this is what the standard looks like. And usually there is a scope in the standard. Again, it is a heavy standard just because it's the basis requirement of any product certified. And it always lists the differences between the older editions and the newer editions. Because sometimes there is a lag between the Senelec adopting the newer versions of IECX, for example. They take a bit of time. So usually, we opt to use the checklist to the newest IEC standards because it pretty much covers the old versions of the standards as well. Let me go to the scope. So you can see here, it talks about the scope pretty much it talks about the general requirements of the construction, testing, and how you would mark your equipment. When we talk about general construction, it references the different methods of protections. For example, increased safety. There is a section in here for IP rating as well, which it calls out the other standard, or when you look at 60079-7, you'll see there are certain sections in the standard that call out -0. For example, thermal endurance of the product. Does it meet the requirements of the tables provided in -0? So basically everything, all different methods of protections on the IECX and ATEX reference back to -0. So for -7, yes, the minimum requirement for the equipment for IP rating is 54, and that includes whether it's a tool, whether it's an enclosure, or anything like that. So, for example, if it's an enclosure, you're going to enclose your product in an enclosure, for example, it has to be sealed so that no dust or water can enter that enclosure. And we can only do IP testing on an enclosed product. We can't just do it on an open-ended product because for sure it's going to fail. So basically there has to be some sort of enclosure for us to test the product to. If that makes sense.
Understood.
Yeah.
Yeah.
So basically this standard pretty much, like I said, it references, it's supplemented or modified by the following parts. So it goes back to all the different methods of protections. And then in the appendix, there is various tables that you can look at. Sorry, I reached the French part. Okay. Again, not everything can be applicable to all the products, but we have to go both clause by clause to see what is applicable to your product. So it's always a good idea to have this standard on hand along with the 60079-7 standard. And usually, if you follow that standard clause by clause, you will have a good idea of whether your product has been designed to meet those requirements before we even get into the evaluation or testing. So that usually helps. So it lists the different tests, mechanical tests, and things like that as well. So I would suggest try getting a hand on this standard as well as the -7. And it'll make things a lot easier in terms of for you guys designing future tools as well. So moving back to the different standards, -1 is for a flame-proof enclosure. In other words, an explosion-proof enclosure which contains any explosions. They would be contained inside the explosion-proof enclosure itself. Pressurized enclosure. There's different types of pressurization, type Z, type X, and type Y. Powder filling, not something that's very common out in the market. You will only find very few products with that method of protection certified to that standard. Same with the liquid immersion. There's not that many out there. Increased safety is one of the more common ones. In the past, it used to be called, it was C60079-15, and I can pull that up here. I believe it was for non-arcing, for non-sparking, if I'm not wrong. Yeah, protection of type N. So basically they changed this to 60079-7 for increased safety. The standard is still valid, but it only applies to hermetically sealed devices. So it doesn't apply to non-incentive components anymore. That's been updated in the standard. So if it was in the past, then we would be looking at the -15 standard for your product, which would have been very similar to the non-incentive. But as you can see, they've changed the name, but pretty much everything in the standard is very similar to the non-incentive electrical equipment standard for CSA and UL. The -10 is for zone area classification. Sometimes, clients just want to go through the area classification of their manufacturing facility. So that's something we get requests for as well, where we classify the area for them. Intrinsic safety, like I mentioned previously as well, that, increase intrinsic safety, you can achieve zone 0, zone 1, or zone 2 method of protection. And they basically define intrinsic safety as an energy limitation in sparks and hot surfaces, where you use intrinsically safe barriers in the product as well, and design it according to the standard with various creepage and clearances on your PCB or any electricals that are inside the product. So for zone 0, that's one method of protection you can achieve. Zone 1 as well, zone 2. Like I mentioned, DA, which is for zone 0, is only applicable to capsulytic sensors. And encapsulation, you can achieve zone 0. Those are the only 3 methods of protection to achieve zone 0. Nothing else. So in your case, if you're looking at zone 1, increased safety is one of them. And I think you mentioned, Ray, in your email, zone 1 and zone 21 as well. Yeah, zone 1, zone 2, zone 21, zone 22.
Yeah.
Okay, let's finish these gases ones, and then I'll get into the zone 20, 21, 22 requirements. Dash 13, pressurized artificial ventilated room. This is usually for anything large ventilated areas where they are processing chemicals or something like that. Basically, it requires an area classification first, and then do the evaluation against that standard. Dash 14 is just for electrical installations, design, selection, and corrections. Like I mentioned, there is non-electrical standards, but before we move into that, I'll quickly go over the zone 20, 21, 22 requirements. Classification of zone 20, 21, 22 is pretty much the same here. You can see it's the same as 0, 1, 2 in terms of the concentrations of dust in each environment, but there is only very specific standards that are applicable to dust. So one is enclosure protection, which is 79-31. It can be certified for zone 20, 21, or 22. This usually applies to any product that has like an electrical panel that can be certified to TB, TA, or TC method of protection. To prevent dust coming into contact with the electrical parts. Pressurized method of protection is one other one that you can certify. So pretty much anyone using like purging or things like that in their product that can achieve the zone 20, 21, 22 requirements. Encapsulation as well, intrinsic safety too. And there is another one which is optical radiation, same as gases. So optical radiation in gases is only for zone 0 and zone 1. Optical radiation in the dust environment is for zone 20 and zone 21. Again, would not apply to your product. So for you guys to achieve zone 21, zone 22, that's something that you would have to discuss internally if you want to redesign your product with intrinsic safety as a method of protection. Then that's one way where you can meet the requirements of zone 20 and zone 21, or zone 21 and zone 22, or have the full device enclosed. Again, I don't think that's ideal because you need to operate this tool in certain environments. So I think the most applicable would be intrinsic safety for you guys. But again, that requires you having to redesign your product according to this standard.
Maybe I'm not reading the table here correctly, but doesn't encapsulation also reference 21 and 22?
Correct.
Okay.
Correct. That just basically means you're gonna pot everything in your product with a pre-certified potting component.
Oh, is that what that means? So something like an enclosure that seals around
No.
No?
So
Okay.
if you use an enclosure, then you're gonna have to look at this method of protection.
Right, okay.
But if you're talking about encapsulating all the electrical components inside your tool, then we can look at it encapsulation.
Okay. All right. So sorry, I guess I should have said enclosure, not encapsulation.
Yeah.
So if we go with an enclosure, it could satisfy 21 and 22.
Correct. But it
Okay.
must be susceptible to dust. That is one main condition.
Yeah. Sorry,
Yeah.
it must be
So it must
protecting.
prevent any dust from going into the electrical parts.
Right.
There should be no dust coming into contact with the electrical parts.
Now, when we say electrical parts, are we speaking about only the battery and contacts, or are we talking about the motor as well?
Any electrical parts.
Okay.
So basically, like I said, encapsulation or intrinsic safety would be a better option, because then that pretty much covers your zone 1 and 2 requirements as well.
Yeah.
Because this standard is only for enclosures for dust. There is no equivalent. There's no equivalence, method of protection in the gas environment for that.
Okay.
And if memory serves, intrinsic safety standards, when we say energy limitation, it's a very low kind of voltage and power, or voltage and current that the device is able to use. So
Correct.
I'm not sure that's viable for our product, because we unless we really nerf the performance of it.
Yeah.
Based on just pouring through it, I think it was like a fraction of the kind of current we currently use in our product.
Yes. Yeah. And that would, mean you guys have to use intrinsically safe barriers and things like that in your product to nerf that as well.
Yeah.
So encapsulation would be the better option in this case. Then you're covered for both, gas and dust environment. So yeah, basically you can see there is a big difference in the methods of protections for dust and gas. There's half the amount for dust than there is for gas.
So
yeah.
the encapsulation approach, you described it as essentially potting. So I assume that means potting all exposed electrical connections.
Yes.
We're not talking about, like, if we have wires, that the wires themselves need to be potted, just the exposed ends.
Yeah.
Correct. Okay.
Correct. Yeah.
Okay. So,
and if you read through the standard, it pretty much talks about, what kind of encapsulation is acceptable as well.
Yeah.
Based on different designs of products as well.
Okay. Luke or Wilson, is that a possibility even in our BREDX?
Short answer for encapsulation, we could encapsulate everything internal in our current enclosure. The challenge we run into is the battery interface, right?
Yeah.
So I don't think that's feasible based on how we're defining encapsulation here, which sort of leads me to ask, is there an opportunity for a hybrid approach where certain aspects of your design are encased in an enclosure that's sealed, and certain aspects of your design are encapsulated? Or do you, once you go with the standard, that you need to adhere to that standard?
Yeah, and I'd made a note on my end saying that I was going to take this up to one of the senior engineers to get some sort of feedback from them, because usually when we run into such a situation, I myself have only come across the intrinsically safe part where, product is intrinsically safe. It has an intrinsically safe output for a certain part of that system to operate in a zone 0 or zone 1 environment, but the rest of the system is in zone 2. So that's a good point. I've noted down here, and I'll take that back to Marion, and I'll discuss that with him, and allow me a few days, and I'll get back to you guys next week on that.
Great, thank you.
Yeah. Okay, so moving on, like I mentioned, there is non-electrical standards. Again, this would be only applicable if there is no electrical parts in your product. The standards applicable would be 80079-36 and -37, which has three different kinds of methods. One is constructional safety, the other one is control of ignition source, and the last one is liquid immersion. This usually requires the manufacturer to provide us a risk assessment, which we would review as part of the certification of a non-electrical product. So if you ever run into that, then that's something to keep in mind. Gas detectors have their own standards. So if you ever get into gas detectors, there is standards for the performance of gas detectors, which apply to gas, like all gas detectors. Talking back about certification schemes, moving to ATEX and the European Union, again, it originated back in the day. In 1950, different countries accept these reports for ATEX and IECX. I would say IECX is globally accepted. Like nobody will ever say, hey, we can't accept this. That is like, I would say a gold standard of a certificate when we consider it as compared to a North American certification. For example, if you take to Japan, they'll be like, we can't accept this. So how I would put it, if I were to put it this way, is you can obtain North American certification based on an IECX certificate, as well as obtain an ATEX certificate from an IECX certificate, but you can't go vice versa. We can't go from North America to obtain IECX based on a North American certification or based off an ATEX certification, even though the standards are adopted and whatnot. But this is pretty much how the schemes work currently. Yeah, this is just a brief background on that. There is an ATEX directive document that I'll share with you guys because, again, like I said, the ATEX directive supersedes all other directives. So you just have to use that to declare your CE conformity. And then any other directives that apply to your product, that's something you would determine and, self-declare for that. This is just listing the new legislative framework for the different directives. But I'll share the document for the ATEX directive with you guys just to have on hand. And then, yeah, this again, if you guys want these links, I can send these to you, seeing which directives apply to your product. But I think so far you guys know that, the LVD is what is most applicable if it's not going to a hazardous environment. So pretty much that and the EMC testing that I believe was done on the product, if I'm not wrong.
I think we also tend to lean into machinery directive as well.
Yes, yeah. So LVD, machinery, but once you do ATEX, everything gets superseded. So yeah, none of that will matter at that point. So like I think you were asking about, about ATEX itself. So basically the word ATEX comes from atmosphere explosible. It's just known as equipment and protective systems intended for use in potentially explosive atmospheres. Yeah. Any questions so far? I think, Ray, the question mainly you have is on the gas concentrations from earlier.
I feel like I've been drinking from a fire hose. There's been a lot of information.
Yeah.
I'm going to have probably a fair number of questions, but I'm going to want to digest it a little bit. So I'm not exactly sure what to ask at this point.
Okay, no worries. Yeah, this is just basically talking about a little bit about our ATEX directive. And this is some of the material that, if when someone is getting into a new certification, we would use it as part of the training. So I just thought I would share it with you guys just so you guys have an overview. And then guidelines, again, these are all available online. If you go to the European Union or European Commission website, you'll see pretty much all the different directives listed there, and you can access those guidelines. Again, this covers product compliance, methods of protections, technical construction file. That's basically the ATEX technical report that we would provide you at the end of the certification. Product markings, this would be discussed during the project. We would make sure we have the correct EX marking for your product, which usually includes our notified body number next to the CE marking as well. and then declaration of conformity is something that you would do on your own.
Yeah.
So yeah, basically here is something, the brief on ATEX and the different categories equipment is certified for, where we can do, a full type certification, or we can do unit verification on a batch of units where we keep track of each serial number. So initially we would evaluate and test one unit just to make sure it is compliant, create a report and issue an ATEX unit verification certificate if that's a path you want to approach. But then every additional unit you want to take to the European market, then you have to bring it to us to verify it is the same unit as per the initial assessment, and then we issue a new unit verification certificate with those serial numbers. It says category 3 here, internal production control. So this is a document that's available online, and I'll try to share that with you, which is pretty much just saying this is why you don't need a quality assurance notification audit for this equipment, because it is classified as category 3. But as you can see, for category 2, and category 1, there is a requirement for product quality assurance as per the annex. And that's basically the QAR, QAN for IECX and ATEX. So yeah, basically, again, this is just discussing the different options for unit verification or type certification. But the technical file for a type certification would include the CE mark, notified body number, and all of that. The report would be a bit different for a unit verification as compared to a type certification. When we do a type certification, we upload that information of your company on our website under the client database, which references the ATEX certificate, which is accessible for any of your clients in the world, similar to your North American certification. But for IECX, it would be available on the IECX scheme website, where you can search up any IECX certificate.
Okay.
Again, talking about category 1, zone 0 equipment requires EU type examination certificate. If it's for type certification, approved quality system with ISO 9001, along with the 80079-34, which is the QAR and QAN. So the ISO is the QAR, the EN at the front is for QAN. That's the only difference there. Same with the category 2, and then here's the category 3, where we provide you a technical report or technical file for the ATEX certification. So it says EC type certification not required. So it is a different kind of type 3 certificate that we provide you. There is a different format for that for us internally as well. So it basically just states that you must have some sort of quality system in place that assures continued supply of ATEX compliant equipment internally for you guys. So you just have to follow that as per Annex 8 of Module A. Yeah. Like I mentioned, unit verification versus type certificate. So there are two options. QANs don't need to be issued by the same certification body. So not necessarily, even if we do the ATEX certification of your product, we don't necessarily have to do the quality assurance notification. You could have any notified body do that for you. Yeah. And yeah, this just talks about what the quality assurance notification is, the audit requirements and things like that. And yeah, I can pretty much share that document if you guys just want to have on hand. That's not an issue on my end. And you guys can take a look, because if you're approaching zone 1, zone 2, zone 21, zone 22, we will need to do those audits. And like I mentioned, yeah, this is pretty much what the marking symbol would be. Next to the CE would be our notified body number, followed by EX, and then the equipment group, which is going to be group 2 for you guys. The notified body identification number, usually we just include it after the CE mark. and then the equipment category. And then for IECX, it would be a bit different. It would state EX, the method of protection. For example, in this case, if it's EB for increased safety for zone 1, then would state EX, EB, the gas group, and then temperature classification, and then GA, GB, or GC. So if it's EB, then the equivalent is GB for category 2. If it's EC, then the equivalent is GC for category 3. And then the G or dust is basically, it states, the gas or dust requirements that the product is certified for. Our certificates would be labeled as LC, the year, ATEX, and then the project number, which would pretty much be a unique certificate number related to that project for you guys. So this is pretty much what the marking requirements would be look like for IECX, like I mentioned. For ATEX, it's a little bit different. It would just be EX to G with the category equipment group. Yeah, so this is pretty much what ATEX would look like. CE, the notified body number, and then EX to G. And then this would be the IECX marking. And we'll guide you throughout the project on the marking requirements and all of that, so that's not an issue. But yeah, this is pretty much covering all of that. I think that is pretty much all I had, other than the quality management system, which we can discuss separately, if that's okay with you guys, or if you want me to go over that, I can go over it.
I'm okay deferring the quality management system for a different time. I did want to clarify something. Just I got a little bit confused between categories and zones earlier on. What's the distinction between categories?
Yeah, so categories and zones is basically, they define it as it's dependent on what zone the equipment is used in. The category is dependent on the zone marking. So if your equipment is certified for zone 1, for example, right, for increased safety, as you can see here, then they classify that as a category 2 equipment, where a category 1 or category 2 equipment would require the quality assurance notification and quality assurance report as per the annex and module A of the directive and IECX. But if you certify a product for zone 2 for ATEX, for example, that is defined as a category 3 equipment, where you must have internal procedures for a quality management system to ensure continuous production of that product, compliant to the ATEX directive, without having any notified body coming to do an audit at your location. So that's the main difference.
Okay, so does that mean we essentially choose which category we want to satisfy, or is that enforced by the?
Yeah, that'll be enforced by the zone you want your product to be certified for. So if we go back to the past, when we were initially trying to certify this product, we were looking at category 3, zone 2 for Europe. Okay. So you wanted your product certified for zone 2. But now if we're going to talk about zone 1 and zone 21, then that means that category becomes category 2, as well as zone 2 and zone 22, which will be category 3. But we still have the category 2 in that certification, basically, if compliant, right? So then that requires the quality assurance notification and report audit for IECX and both ATEX.
Okay.
So that's the main difference, yeah. So it's basically determined off the zone requirements. And yeah, but just to quickly go over this, increased safety as a method of protection. The principle itself is conservative spacings, connections, and pollution protection that reduce the chance of a spark or high temperatures. Very similar to the non-incentive electrical equipment certification. If you read the scope for the CSA 213 binational standard with the UL 1201 that your current product is certified to, it's very identical, I would say, in that sense. Except when you get a product certified for increased safety, it is not accepted in division, and vice versa. When you have a product certified for non-incentive, we can accept it directly for zone requirements. Inspection points. This was something that Ray, in your email, you had said, what is something that we can look at during our design process. So these are some of the items that you can look at, material usage, built to print, enclosure damages, any weld continuity, any creepage or clearance distances. Again, these are stated in the standards. Any connectors, connections, tighten per schedule, gaskets and glands, and routine tests on your product. So those are some of the key things to keep in mind for this method of protection itself. Anything related to motors, terminal boxes. Again, the main thing in this standard is clearance and creepages. That's something just to keep in mind. Marking requirements, again, the standard states, these are the wire sizes you need to use. This is the gauge of the wire and things like that as well. So you can take a look at the standard. Moving on to encapsulation. So keeps gas out and limits hot surfaces like we discussed. Inspection points for that would be any cement or compound material, shelf life, any processes, routine tests, anything visual. And I'll definitely get back to you guys regarding the battery interface and what the solution for that could potentially be in terms of certification. So that's something I've noted on my end.
Just on the topic of the battery interface, something I've seen in some other products is the battery has its own enclosure. But some products I've seen, they actually encapsulate the whole battery and enclosure and everything to the product. And that's probably the simplest path forward for us if that's a feasible solution.
Yeah, correct. Because you see, you guys do need to remove the battery to charge it. I don't think there is any other solution to that unless you have a cable going into that potting to charge the battery, which is, I believe that's a much difficult task when you think about it, given how these batteries are designed as well. And again, all this charging has to be done in a non-hazardous area as well as your current product that is certified. It probably states that in the specific conditions of use as well.
You got it. Yeah.
Yeah. So, and just to quickly go over intrinsic safety, maximum open circuit voltage or short circuit current combined to provide limited energy, so it cannot ignite. So something, Luke, that you touched on. And there should be no thermal ignition source. When we do testing for intrinsic safety, there are 3 levels we can do this to. If you would like the product certified for zone 0, then we would test your product for no ignition with 2 countable faults. If it's for zone 1, then for no ignition with 1 countable fault. And if it's for zone 2, we would just test the product with no countable faults applied to the product. So this would be something that you would have to give us designed with countable faults, at least during the testing phase of the product. So if this is something you consider. And the applications, like I said, you can use this in zone 0, division 1, zone 1, division 2, as well as zone 2, as well as zone 20, 21, 22. It's applicable to both gas and dust environments. And then again, inspection points on this would be, correct parts, PCB spec and revisions, coatings and encapsulations on the PCB, markings, routine tests, any barriers or transformers that you use in the product. Most of the time, clients opt to use pre-approved intrinsically safe barriers or transformers in the product. And again, creepage clearance will come into play. It's listed in the standard in the tables in the appendix. And yeah, that's pretty much everything. So like we mentioned about the GA, GB, GC that I was talking about, depending on the zone we're certifying the product to. So it provides an equipment protection level GA when single standard types of protection cannot be applied. this is again not common. So that's pretty much, it's not applicable to your products, I would say. And then the optical radiation, again, this would not apply to something that you guys manufacture in general, in terms of tools, because it's related to optical radiation. Unless you do use any kind of optics in your product, then this is something you can consider in the future for IECX and ATEX.
My mind thinking laser devices and stuff like that.
Yes, for sure. For sure. So 79-28 will come into play if you get into that design phase for those products. Dust methods of protections that we went over pretty much, there's various, like we mentioned, for protection by enclosure, encapsulation, pressurization, intrinsic safety, and then non-electrical equipment as well. And again, that's something that would not apply to you guys in any case. So there is this 79-14, which is for installation considerations for EX protection methods for gas. This is usually for equipment being installed in certain areas. Again, not that it would apply to any handheld devices that you guys design and manufacture, but just for something for you guys to know about. So yeah, for installation for such, you would look, I mean, your tool is used outdoors to a certain extent, right? Like not, is it used in like very harsh environments, for example?
I'm going to say yes, but I don't know how to characterize that.
Like I would say harsh environments, like environmentally harsh conditions.
I
So
mean,
like, minus 40 weather, it's snowing or like there's ice falling and, you're continuously operating that equipment in that sense.
there's how to put this tactfully and carefully. Do customers use the product outside of what? Yeah, I'm not sure. Generally in those applications where we're dealing with really extreme environmental conditions, we have different products that customers will go to, like our pneumatic tools and things like that.
Yeah.
However, is there an opportunity there for us to kind of further develop and certify our battery product for those environments? Yes.
Okay, so when you say yes to that, I would say just keep in mind for North America, any product for outdoor use to certain environmental conditions, you would have to, when we do the general safety certification for future products, for example, like this is when you guys are in the design phase. There's a standard UL 50E which has a CSA binational 94.2, and that talks about the different environmental conditions products can be used in, and that pretty much covers any ice environments and things like that. Most of the time we come across this when people want to use an enclosure in an outdoor environment, and they don't realize that, oh, I did not consider it for use in the outdoor environment, especially if it's not a pre-certified enclosure. So for North America, they look at NEMA ratings. That is the requirement. But for IECX and ATEX, the IP rating is pretty much, it covers all of that. Again, if there's no dust or water penetrating through the equipment, then it can be used pretty much in any environment, because then the battery is certified separately for its condition for a certain environment as well. So that's separate. But this is just for you guys to keep in mind for North America. But yeah, that's mainly what I had to share with you guys. And yeah, any questions, concerns? I know this is not like a training, but I thought it would be a good overview for you guys, especially, at least the ones that are not familiar with the hazardous locations at all. So I just thought I would share something that we use as a base training material for you guys, just because we don't have any of the engineers available, I would say, for formal training right now. But we can definitely organize that if that's something you guys are interested in, for the different methods of protections that you think would be applicable to your products. And we can definitely dive deeper into those standards, look at certain items that you guys have specific questions for related to the standards, not an issue on our end. We can definitely work on that, prepare material for you, and hold a training session for your team.
Yeah, I think we'll have to regroup a little bit and figure out our next step forward. This does give us, I think, a bunch of good things to examine.
Yeah.
Is that presentation something that you're able to share?
No, unfortunately, that document I won't be able to share, but I'll put together an email with everything we talked about, and I'll give you guys a brief, and I'll list all the standards and things like that, the links to the directives, the directive itself. I'll share that with you. I'll share the audit reports template and things like that. And then if we do have a formal training, whatever we prepare, we'll potentially be able to share that.
Okay. All right. That'd be great. I think what I'll want to do with the team is kind of organize to see if we have I don't know, I'm going to say a flow chart of how we go from where we are now to how we get to the stamp
Where
on the
you wanna be.
product so we can sell
Yes.
it.
Yeah. And I have some action items on my end. So let me try to discuss those with Marion when he has sometime late this week, early next week. And then we'll get back to you on those items.
Okay. All right. That's awesome. Thank you so much. I found that quite valuable. I don't have any other questions myself. Anyone else on the team have any questions?
Not from my side.
You've kind of addressed all my questions and concerns, and thank you so much for going through all of this with us. Really appreciate it.
No problem. Sorry, I did go over time, so I apologize for that. An hour
No,
is
it's
usually not
perfect.
enough for an overview. But yeah, my recommendation is, get the standards on hand, just read through them, and usually just reading through the standard gives a better idea of just rather than an overview and relying on the certification body to do the evaluation, because then you run into that risk of non-compliance, similar to when we were doing the certification for North America, and then the ATEX portion, pretty much we hit the wall there, if I recall correctly at that time, so we dropped that. So usually a good idea is to go over the standards. It really helps, and we're always here to assist in terms of answering any questions or concerns you guys have, and we'll do our best from our end to address those.
Great. Okay. Thank you very much then.
No problem, Ray. Have a good day, you guys. Yeah.
Okay.
Thank you.
Thank you.
Thank you.
Bye.
Thanks
Take
again.
care.
Thank
Bye-bye.
you very much.
Thank you very much.